I have learned a lot from this community. You are great. And you're doing really cool stuff with functional programming in industry, which I teach to middle school children and high school kids and freshmen and master students. And so it's a real pleasure to see that. I wish I had a day to tell you all the mistakes I saw that we made, and you're making them again, but I don't. So as Mark said, I'm the man. I'm the man who stands between you and the party. And it's worse, I'm a professor, and I just can't leave it. So I was thinking of giving you a lightweight talk about the weather. I'm not. I'm going to give you a lecture with pop quizzes. And we'll practice this pop quiz stuff right now. Okay, ready? Okay, so here's how it works. On occasion, I will give you a question, and I expect this audience to participate. That's how it works. I actually usually know all the names. I can call on people by name. I don't have time for that now. So a few years ago, 3 years ago, I wrote a book with 8 freshmen at my university. Now they're not freshmen anymore, they're actually finished. And we published that with no starch and O'Reilly label. And I will call out questions, and if you answer those questions, you will get a copy. Okay? So we'll practice that now. I'm just going to call out a question, and I pick somebody who answers correctly. Who can stand up quickly? Okay. It's this one. It's absolutely. It's not because it's the front row. I don't mind walking to the back row. Okay. So just do it. Okay. So yesterday morning, Claire, who spent a lot of time in my lab for 2 or 3 years, working with me, stood here and gave you a talk that apologized for using the word type over and over again. I felt really bad for her. Like, here she stands, and here's apologize to the community. So, if you know this picture, it's from a little current country album. I feel like the types are misunderstood here. It's like this song, Mr. Misunderstood. This little kid sits in the back of the classroom, and he just doesn't get it. It doesn't get any attention, and you're ignoring him. And I did too, for a long time. And I learned to appreciate this guy over many years, and I want to tell you that story in an hour. So here's my life story. I'm condensing 35 years of my life for you in 1 hour. It's hard, but we'll try. Okay. So what I did was, I started out like many of you in an imperative world with dumb types, and then a couple of years later, I switched to Prolog, Untyped, right? And I went to Scheme and other things, and you see the whole life here. I won't tell you what the life exactly is like, but there's stages where I got to realize types aren't completely evil, right? And so as the first stage, this orange stage, where I started thinking about them and publishing about them, but I always stuck to untyped programming. And I am known as the academic, the only fool academic, that's what they call me there, who sticks to untyped language, because everybody knows types are the thing to do. And then there's a red phase when we started doing Racket, and we realized, it's red because it's really hot red, over 20 years we maintained a code base. And maintaining a code base really, really brought home to me what it meant to have those types in your language, even if you start out untyped, like all of you do. Okay? So that's the story I want to bring across, why I migrated over 30 years from a love of untyped programming to appreciating types. Okay? So there are 2 notions of types. There's the one that tells the compiler, allocate that many bits and make that run fast. And I don't care about that one. I just don't. I want the types that tell me, the developer, and I do develop code even as a professor, right? Tell me something about the program, something that helps me work with that code that I'm writing down. So that's what my focus is, okay? And when I say maintain, I want to give you just an idea what the code base was like a few years ago. 500,000 lines of code. I've heard people here call a code base of 10,000 lines big. That's a little bit bigger. Okay. And when you do that, when you talk about development time, what I'm interested in is a very simple phenomenon. You develop something, you deploy it, and then you have to do more work. And what you see, and you deploy it again, and you know the whole cycle, you know the cycle. And what's really going on is that what you do at the front end affects the time you spend afterwards on that code. That should be called development time. Don't just call the first little step development time. Okay? Good. So, in that spirit, types are like the weather. Right? So sometimes the weather is just fine and you don't care. You go out there, you enjoy it, you don't pay attention. Sometimes, you have a nice landscape, you enjoy it even more because you have a day off. The rain is over, the rainbow comes out. Who cares? You don't need an umbrella anymore. But then you have that. Is anybody from Tornado Alley here? You know what I mean, right? So yeah, there we go, right? You want to know when that thing is coming tomorrow. Or if you have lived at the Gulf Coast and through two hurricanes, that's what you go with. You want to know that these things are coming in. Okay? That's true too for computation. When things go right, you get an answer. Often they don't. And for those of you, oh, that's cool. A lot more people laughed than I thought would laugh. I thought they had eliminated that one, But don't get smug. The Linux people have the problem too. And in this day and age, of course, you don't have blue screens of death anymore. We have exceptions. And they exist in Clojure too. So, wouldn't it be fun if we could think about the weather and the types? Well, 50 years ago, 100 years, actually, weather reporting became a big thing in World War II. And then they developed it afterwards for all kinds of purposes and very applied purposes, from oil platforms in the Gulf to cornfields in the West. And they're very important purposes. And so what people figured out was you can write down, you can look at today's weather, so to speak, or something in the world, and you can write down a bunch of math. And then what you do is you turn this into pretty pictures on TV. Okay? And they distill this math into stuff that is good enough. Just good enough, right? And tomorrow you actually experience good enough. You stay indoors because there's a thunderstorm, or you go outdoors because it's a great picnic time, right? And the predictions aren't perfect by any means, but they're useful, okay? And they are kind of accurate. And if you notice, the weather reporting, my age group, knows that weather reporting, weather prediction have become much more accurate over the last few decades, right? The other thing is, of course, they're partial. You don't get a complete weather report. That can give you a lot more details, but even they don't know everything. So what you get is little hints, little pictures. And it's good enough. You just look at this icon, it's sunshine. Or as a hurricane coming, I'll stay indoors, or whatever, right? And the question is, what's accuracy? Same is true in programming. You can write down code, and you can actually write down equations about that code. Or you can write down your thoughts about this code, and we synthesize equations from this code. Okay? And then we distill this and check what these thoughts, your thoughts about the code, predict about running that. Okay? And then you get 42. And the predictions, just like the Weathermen, they're partial predictions. They're not complete, but they're useful. I promise you, I'll show you some uses. And the question is, how accurate are they? Or if they're not accurate, how bad can they be? So here's two little predictions, and you can write many more. The first one is a function, and it says, give me a number, and I give you a number back. Of course, you can read code, and you can do better than that. You know it's a square of that number you get back, right? Or if you write down funxx, you know that whatever you give me, I give you back, right? That's what I mean by predictions. And we can check those by checking the context of the string, by checking the actual inside of the function, stuff like that. And the question is accuracy. What does it mean? Right? So what you take away from this part of the talk is that types are the language of predictions. Yeah, your language of predicting what happens when you compute. Okay? Type systems check your predictions and let you know how good you are with them. The question you need to ask is this useful and is it meaningful? And I'm going to roll up these questions backwards because meaningful is very important. And we'll get back to this at the very end of this talk when I talk a bit about type closure. It's often called soundness. It's called type soundness. And I will tell you at the end of this part of the talk that it has nothing to do with types. You'll find out. So this is a computation. It's a random walk through the land of bits. Often I call it the sea of bits, and you'll appreciate this because you're programmers, right? You go along, and your compilation may be stated in Clojure, it may be stated in Java, in Racket, but eventually it's compiled down to the things that everybody on the street knows computers do with things, bits. And so you get to this place where you have a bit string, and you have another bit string, and you add the bit strings together. Right? But what if some of those bits don't actually represent a number? What you, the developer, thought would be a number when it gets there. It's an odd thought, isn't it? And I know some of you know that this works, and some of you have maybe surprised. Okay. But the machine doesn't think. The machine is told, here are two bit strings, add them together, and the CPU, the coprocessor, whatever, will do that. And the question, can it happen? Right? And the thing is, in unsafe languages, this happens all the time. So unsafe, unsound, right, same thing. Bits are bits, life goes on, we just continue computing. Because that's what happens next, right? What happens when you add the character C to the value true? It's perfect addition, right? In bit strings. If you're lucky, if you're really, really lucky, you get a blue screen of death. But usually you're not lucky. You get an answer. And it's close enough to what you wanted. Let's go with it, right? That's an unsound language. So even during testing, if you take that path, it may just look like you came out okay. That should scare you if you think that this code is in your grandma's heart pacemaker. Right? Because it just outputs stuff. And sometimes it will output 42 million instead of 42. And the heart rate goes up or down. Okay. So how about a sound language? In a sound language, you get to the same point. And for some reason, somehow we figured out that you're not adding two numbers. Okay? And you immediately get an exception. It stops right here. But there's this little picture down there, and all of you are curious to see what it says, right? Okay. If that exception is raised in the operation room during surgery, well, your instruments go down. So maybe exceptions aren't that much better, right? Well, I want to bring this across because I'm a scientist. I'm not an ideologue. I'm not going to sell you one side or the other. I'm going to show you there's a spectrum of things. And the spectrum here is question that you can ask is, are developers better off? Most of the time, yes, because you get the exception during testing, and it very much nails down the source of where things went wrong. That's not necessarily where the logical bug sits, but that's the source where you can trace it back. That's huge progress over the fact that the computation just goes on and says 42. Are users better off? Most of the time, yes. Because they don't purchase an aircraft when they want a pair of shoes. Or something else goes wrong, right? Okay. Something goes wrong early enough, and worse things don't happen. Okay. So that's what you see here. Okay. So soundness really establishes very important characteristics of all language. Safety, soundness, bring across what happens at the bit level seen from the source level. And we want that. Okay? So I'm giving you takeaways, and I put these slides on somewhere on the web, and you can download them so you know what you learned in this part, right? Oops. As I said before, it's a spectrum. It's not a binary decision. Academics always talk about a binary thing. It's sound or it's not sound. I believe it's a spectrum, and we just moved over on the scale from really, really evil to it's okay. Okay? The question that should be on your mind is closure type sound? Okay, let's practice pop quizzing because I see you falling away. What do you think? Hands up. Okay, you lost because there's not a single answer, right? So I can't give you a book. Okay, that was a dirty trick. Okay, I'll do better later. It turns out that so-called not all, but many untyped languages actually have one type. And that type is a simple prediction. The program will start running. I don't know how far it gets, but it will start. Okay? And that's if you hang out on the slum called web, then you know that this is due to Bob Hopper. It's actually not due to Bob Hopper. It's a quote from Dana Scott from the 1970s that he requotes over and over again. And Bob and I go back a long time, so he will forgive me when I say that. Okay, so what I say is, and he says that, by the way, he agrees with that, a language with a single type can be sound. And in that spirit, closure is mostly sound. It's weird, isn't it? So closure has no types except for one, and every expression is that type, and it's sound with respect to this type. That's not a bad thing. So question is, how useful is it to have one type? So this is my Bob. This is my answer to Bob, right? Well, let's say what it means. If you're in closure, you have the one type. So everything in closure, like the variable m here, has the type. The variable x, the function definition at the bottom, it has that one type. The function over there, it has that one type. Does it remind you of something? It ought to remind you of the languages that you hate. Because they also have one type. Well, they have more, but in reality, you use one type, the type void. Over and over again. My method takes no inputs, it returns void. My for loop, it doesn't do anything, it returns void. Void, 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 void. Right? That's all you get there. It's not very practical either. Because as a functional programmer, you have many more thoughts about how your program will run. You have much more sophisticated thoughts because you are dealing with little mathematical things. Okay? And so you know that M isn't just the one type, it's a map. And you can be more precise than that. Or that thing over there is a func. It takes no arguments, but it gives you a string back when you run it. And the thing down there is a function, could be a function, that takes in one of those functs and then returns a string. Okay? So these are much more sophisticated thoughts. They're not perfect thoughts about what these functions will do, but they're far more sophisticated, right? Okay. So then what's really going on is you have thoughts, and you can't write them down. And that's a real problem. Because code is written for the next developer to read it. And by the way, it also runs on a computer. I wish I were the first one to say that. I'm not. It goes back a long, long time. Okay? But that's, if you take nothing away from this talk, that is something you should take away. Okay? It's for other people to read. They read your thoughts. But you can't even write them down. So let's look at a very concrete example for my Racket world. So I got this program as a Christmas gift. Don't laugh. I kept telling my PhD students I had grown up on Algo 60, and I loved that little language, and it was wonderful. So Matthew Flats, the guy who creates the bottom of the Racket Beast, he implemented Algo 60 in our framework, which is a language for programming languages, in an afternoon. It used to take 5-6 years to create an Algo 60 compiler. He did an afternoon, shipped it off, and I played with it. And I started running program analysis on it. And of course, we found a mistake somewhere deep down there. At the time, the thing was 800 lines in one function. Matthew is a really great programmer. I trust him with my life, but he sometimes makes the long functions. Fortunately, he was about to come out. That was like in February or whatever. And so I sat down with him, and we looked at the problem, right? We looked for what's going on. And he sat down with me, and 20 minutes later, he had figured out what the parameters of that function were doing, what they stood for. Only 20 minutes. What's that, considering a whole lifetime, right? 20 minutes to reconstruct. Because the only comment he had was actually, start reading the compiler here at the very top. Okay. So clearly we learned our lesson, and we wrote down a comment. You see the comment? Pop quiz. What's the problem with that comment? You, come up. Oh, actually, tell me the answer first. More precise. Almost. What? No.
When your program changes, the comment doesn't.
Getting close. Keep going, keep going. This is a pop quiz. Come on.
It's wrong.
Yes! Yes, it's wrong. Come on up. Good job. What was your name?
I'm Bryce.
Bryce.
I actually couldn't read it. I just guessed.
Yes. Yes! Yes! You're supposed to guess. That's exactly the right strategy. Because it's obvious. There's a theorem out there. All comments are wrong all the time. That's, of course, not true. And I make these digest statements, but it's really what's going on is comments are it's a spectrum. It's never binary. Comments are mostly okay, and they convey a sense of what's going on, but they're not really perfect. Right? That's a better way of saying it, but they're all wrong all the time. And you can see here there are 4 things supposedly going into the function according to the comment, and we wrote down these nice little quasi-types, but they're actually 5 parameters. The program changed, right? Something like that. So we learned our lesson. We slowly started adding types to Racket. And we wrote on, in red is a good stuff, right? We wrote on types. And what's the advantage? The advantage is you can check them. Like somebody said, comments aren't checked. Okay? Types are checked. And so now we know, next time we read that code, and we will read over and over again, we know they're checked, and then predict the computation properly. So when we have a bug, we can go back and say, what's wrong with the prediction? We can rely on these things. Okay. So it's not just for maintainers. Now this is a little plug. It's not really commercial, but that's the book that Mike talked about, the one on the left. But the way I write books is I write them on the web first, and then I force publishers to buy it while leaving the text on the web. So MIT Press publishes this book very happily, but the whole text is online. Okay? what this text really teaches is, if you think with types as comments, you create programs with the right organization. That's what Mark was trying to say, or was saying from introduction. So types, even in untyped language like Racket or Closure, if you write them down as comments, will help you organize your program properly. Recursion is no problem from here on out. 4 weeks into the first course you ever take, you eat recursion during daytime and you dream of it. No nightmares, wonderful dreams at nighttime. Really. So that's the end of it. So, takeaway from this part is, all of you think types all the time. Sometimes a bit more refined, sometimes a bit less refined. But you think them. It just happens to be the case that Closure won't let you write them down. But if you can't write them down, you can't check them, and the guy that follows up on you has to reconstruct them. 20 minutes per method, or something like that, for a good guy. So if you are not married, if you don't want to spend time with your kids, if you hate vacations, that's the way you program. Okay. Or if you are running a startup and your venture capitalists have no limits on the funds they're going to throw at you, that's the way you run the company. Okay. But I love untyped programming too. So what can we do about this situation? How many of you have heard of type inference? Good. The answer is okay. I'm a researcher. I don't give answers like this without justification. I have opinions, but these opinions are typically established over years of working on a problem and then working out why the answer is glib, no. I spent 15 years of research exploring 4 different approaches to type inference on untyped languages like Scheme 84, Scheme 88, PLT scheme, Racket. It doesn't work. That would be another hour-long talk on explaining why it doesn't work. And I'm actually giving a talk like this in the at the carry-on version of this kind of thing. It's more strange Lobish in Europe in a few months. I give you a bottom line insight. Okay. And Bob Hopper told me that as I started on this work. If you don't have a language of types in mind, inferring types inferring types that programmers really care about is nearly impossible. And then there are lots of technical problems. And the real problem is when things go right, nobody cares. Everybody is fine, dandy, okay? But if things go wrong all the time, because they have type errors, right? Then you have to come up with error messages that are informative. And you don't get them. It's just impossible to get good ones. Even for the ML guys or the Haskell guys, you don't get good ones. So don't go there. Okay, no type inference. We're going to write down our thoughts. We're actually going to write down our thoughts, leave them behind for the next guy to take over. And the next guy to take over could be you, 2 years older, or 2 days older, and you forgot what's going on. Well, all of us get out, the other air sooner or later. Okay, so how should adding types to an untyped language work out? When you have a reasonable sized code base, like this one, you cannot put your team there overnight and say, spend 2 more hours tonight and put types on all the 500,000 lines of code. This doesn't work. You want to be able to add those things very gradually, incrementally. Basically, what you want to do is you want to add them like this. You have a bug, or you open some file to add a feature, and you have to reconstruct something. By golly, now write it down. And if you don't have to open the file, leave it alone. That's incremental, right? It's actually easy. But here's another thing. You live in a community that's untyped. I live in a community that is untyped. We develop our own idioms of programming. Okay? If we add a type checker that forces you to rewrite working code, of course you're going to get mad at me. All you should have to do is write down your thoughts, your type predictions on the variables without actually touching code. And we can do that for 98%, 97% of functional code, and you don't care about the other kinds of code that we write because they're not welcome here. I understand that. The imperative, okay. Right. Finally, you want a third property. That is something like soundness. You want to raise exceptions, or you want to get type errors that make sense to you. I can't go over the whole thing, but I'll give you some indications of all three in this last big part of the talk. So I have this nice little module. And I have wonderful comments that say these functions f, g, and h take non-empty lists of numbers. And then I'm going to call this thing on the empty list. What's going to happen? No. It's untyped. It's comments. Runtime error, yes, and? This is a pop quiz. Come on, guys. Exception. Where's the exception raised? Anybody see it? Last line. Right. I couldn't see. I think it was you. So if it wasn't, you're lucky. He's the... What's your name?
Venice.
Venice. There we go. One more. Bryce, Venice. Okay, good. Good job. So what happens is this empty list flows in, and all of you have experienced that in some shape or other. It bubbles down from F to G to H inside, and then it says, that can't be a first or a car of an empty list. Don't tell me. You have never seen this ever? Okay. So, of course, you don't know where this empty list came from. So what happens if you add types? Right? If I add sound types, non-empty list may not be a type that I really check. But if I do check it, and I do call f on empty list, I get that error right here at the top of the chain. Okay? At the top of the chain. I don't have to think through 6, 7, 8 layers. I got it at the top. I can go home, play with the kids. But they're 25 and 30 now, so they don't do that anymore. Okay, here's another one. This is untyped idioms. This is probably the code density slide of the talk. So I'm not going to go deeply into this, but I'll give you an idea. Oops, too many parentheses. Who would have thought? Okay. That comes from copy and pasting from running code, sorry. So on the left side, I have this informal comment. This is a program that I teach beginners in the 4th or 5th week. So a shape is this thing that's either a square or a circle has a radius, a square has a size, and a const pair of two shapes. Like you can put together two shapes, and you have a tree of shapes, and you render them on the screen afterwards. And you have little examples at the bottom. That's the left-hand side. And on the right-hand side, you have a function that computes the approximate area of such shapes. Just approximate, like pi is 3. This is like Indiana, right? So I got my PhD there. It's actually true. I checked it out. The law exists. Nobody knows? In Indiana, pi is 3. 1860-something. So anyway, so of course, you lay out that function on the right exactly according to the data definition, there's comment on the left. Okay? And how do you think about that code? The way you think about that code is, I'm getting a shape. Okay? And when I see a circle, on the right-hand side of my conditional, so this is how we write conditions, const, right? You know that S is no longer just an ordinary shape. It's a square. You know that. So that's how you think about that. Very simple predicate-based thinking. It's called predicate logic, actually, but you don't have to know that. Next line down, you know on the right-hand side of that cont, that's not a shape. It's a circle. You know the S now stands for circle because I tested that with circle on the left-hand side. And down here, I know that S and S are shapes, and I even know that they're smaller shapes than the one that was given, car of S and could of S, right? So that's the kind of idiom we think with, right? Think about any type language you know. They don't do that. You in Clojure world, you write code like this too, and you think that way too. Okay. So what you do is, you take one and the same variable, and it stands for different types in different places. Now, when we add types in type record, all we really do is, like I promised Incrementality, we only add that line. We turn this comment into a type annotation on one variable, the area function. And our prediction, our weatherman, goes through the code and makes sure, oh, he gave me a shape. But now I know that I tested circle. So I know that on the right-hand side of this cont, I actually have a square. Sorry, circle, square, whatever, one of those things. So you get circles and squares. The type system knows how to cope with a variable, the same variable, in different places having different types, subtypes. The way set-based thinking works. You may never you may have never heard of sets, but you think with sets in Clojure all the time. I have a big set of shapes, but now I'm dealing with circles, which is a little subset. That's how we think. And the type checker has to accommodate those idioms. Okay? How it does it doesn't matter, but it has to do that. And what we call that is occurrence typing. And we have many more tricks in the type checker and the type language to accommodate untyped thinking. Okay? So that's what I mean by accommodating the idioms that you have grown up with, that you've come to love, that you use on a daily basis. We don't want to touch them. It's working code. The most we want to do is add an annotation that says, this should work. Okay? Incrementality. So I don't want to talk too much about it. So that there's in academia, there was a co-invention of this idea of explicit gradual typing. It's called incremental typing. And there's a spectrum. In type record, we have real modules. Think of a file, if good enough, with a few extra specs. In reticulated Python, which is a reasonably new creation, they let you not just deal with an entire module that's now typed. Wherever you want to write it down, they deal with it. And they let you do it on an expression level. It's much more incremental, much more gradual, and there's a spectrum in between. So Facebook has created a typed PHP. Microsoft has created a typed JavaScript. They're using these things, and they live somewhere on that spectrum. Okay, so there's a whole bunch of these languages have followed up on our lead and do that kind of stuff. And of course, type Clojure exists somewhere on that spectrum, and I'll talk a little bit about it later. So what does it mean? Let's go back to soundness. What does it mean to have a module, right? A module is like, in our world, so Racket is not a language. It's a family of languages that is extensible and you can make your own. So the first line of every module says, I am in my favorite language, which in this case is Racket. Then you can do your provides, and you can put them anywhere, but I put them in the top. And you can say, I'm exporting only one function. I'll call this function redo or delete or whatever call it later on. Then I have some comments, right? Right here, it says it's a string and a natural number, and I get a string back. And of course, the function definitions and so on. So now suppose I export this thing. That means I require, like in Clojure land, I require this file. And I call this function. I call it redo, and I call it delete. I'm sorry. The talk isn't finished. So, but I'm giving it. So you're importing this thing, right? What does it mean if I move one module into typed land? And all I do is I say type record in the first line, and then I turn comments into annotations that I check, and if they're not okay, I will fix them, but this is what these things look like. So now I'm exporting a function from typed land, where it was type checked, to untyped land. Who can tell what the mistake is? You were first. Okay, your name? LVH. He got it. So what should happen, right? What should happen when the typed land gives the untyped land a function and the untyped land has a mistake? Maybe it's only discovered now. You know what should happen? That wasn't a pop quiz, but come on up. You don't have a name tag. You're like me. David. Okay, good job. Well, 2 modules is not how we operate. I don't actually know how many modules we have, but it's in the tens of thousands. So what if some of them are typed and some of them are not? And you keep exporting. Say the leftmost is typed. You see the red thing in there. And all the others are untyped. And just keep on passing along the buck. Like back then, the buck stopped there. That was Truman. But now we have somebody else. And you end up having a mistake down there. Far, far away. Different galaxy, right? What should happen? What happens in type record? We tell you exactly where that value crossed from typed land to untyped land. And say, this is where you have to fix something, because you have assumptions that later on, way down the road, cause an error. And the only place you can fix it is at that boundary. Because you made an assumption in the typed world about the untyped world, how you would use that value, and that's wrong. So somewhere in the middle, you need a module, an adapter that does that. And there's actually a mathematical theory behind that that tells you exactly why that is. And it's a theorem of economic value. And we can talk about this later if you want. I see your questions. Don't worry about it. Okay. How do we do that? What we roughly do, we call these things contracts. You might call them wrappers. They're really proxy values that the chit knows about. We wrap those things that flow out of typed land into untyped land, and we remember where this assumption that there would be okay in untyped land is established. That's the boundary. Okay? And then when something happens, that's how we can point back. Of course, it carries along predicates and stuff like this. Details are not really too important, but that's what happens. Okay? Yes, yes. The question was, did the error surface in the untyped world? Yes. The untyped world treats a function from integer to integer by applying it to hello world. It shouldn't. Something went wrong. Okay. This saves the developer tremendous time. We know that, because we know exactly where to search for the misconception that this function would be okay to live in untyped land. The developer can do that. Okay. Here's the key question. This is where it's really closure-ish now. What happens if we don't use contracts? If we don't establish a firm boundary between the typed land and the untyped land? That's not true. If we don't have these proxy values that monitor how you use typed values in untyped land, here's what can happen. On the left side, with red annotations, I have type closure. And it has implemented a voting machine. And one of those voting machines could be a setup where I say who you can vote for, like Donald, and it's used, it's imported into an untyped thing, top right. And you set up your ballot. And the first guy on the ballot is Donald Duck, right? And what you do is you export the function that also says, let me update the votes that Donald Duck got, or the other guys on the list, right? And of course, you know that vote additions from a precinct can only be natural numbers, counting numbers. 0, 1, 2, 3, right? Okay. So we're exporting this thing with the second line. It says, I am taking a name and the counting number of votes that this guy got. So now I'm exporting this function to an untyped module. Okay? So what do you think will happen? Let's think through. So on the right side, something odd happens. I'm having negative votes from a precinct. What do you think is going to happen? Here's hand up first. Come on. No. No. One more pop quiz. There we go. Your name was?
How many more books do you have?
You can't get more than one. Did you have already one? No. Okay. HE. So by the way, if you got a book for pop quiz, don't come a second time. I know you're all good and really good students. So if you export that without checking that the function always consumes natural numbers, it's okay. It's perfectly okay to pass in -234. Nobody will check how you use that function. And of course, inside of typed land, we had already checked that you only use non-negative integers. We can check that. Damn. So now we just tricked Donald Duck into losing 234 votes. The calculation goes on just like before. You have reopened the door to completely unsafe C++ style programming. That's what unchecked optional types do. And unfortunately, that's what type closure does. And Ambrose knows. That's why he's now a PhD student. Okay. So that was a long part. It's types for untyped languages. And here's the list of things that I think are critical to make this work. You must teach that type system your idioms. Mostly works out. Sometimes we have idioms that we don't speak. For example, we have classes as first-class values in Racket, and we took us 4 years to figure out how to deal with that, because nobody had ever thought of this in Typeland. And Asumu Takikawa just finished his PhD on that a couple of weeks ago. The next thing is we need to be gradual. And how gradual isn't clear yet. Until recently, I thought module level was good. I have now, one of my research scientists went to Microsoft and is using typed JavaScript. And there you can do much finer-grained gradual types, and he is unbelievably happy. So he's, again, like me, he's an untyped programmer, but he loves to write down types for complicated functions. And he says this very fine granularity is really cool. No soundness, no business. You're going to lift the problems that exist only at the bit level to the source level. Congratulations. It's not progress. It's a step back. If you do have it, you get two things out of it. You will get a heightened sense of security because types establish once and for all that certain properties hold. Once and for all, they say this computation will behave in this way. Okay? That's really cool. It's a for-all quantifier. Assertions check that for particular values that flow through, these things work. Predicates for one value that flows through, or 3 or for 5, but not for all. And the other one is it reduces developer time. And as I said before, if you're happy not having time for other things, then maybe you don't want them, but that's what it does. But there's a problem, and I'm a researcher in addition to a developer, and I will admit that for a long time, we didn't know what the cost was. And to my embarrassment, the cost is much higher than I expected. It took us about a year and a half to figure out a performance evaluation framework. Again, I don't have time to talk about this here. We just published an academic paper about this, and at the moment, I will just call this an open research problem. Some of you may have seen the tweets about my paper there, and it says gradual typing is dead, or type closure is dead. It's not true. It's not true. Just like Lazarus, we will resurrect this guy. or you may know the movie where it says dead is not, almost dead is not the same as dead, right? Anybody know the movie? Princess Bride. There we go. Okay. So, 5 minutes? 15. That's perfect. Big takeaway. Big takeaway. I will let you read the next slide. That's what you will find on my homepage. And that's the first thing I show every freshman who wants to learn to code. You really want to think that way. And you almost want to think that there are psychopaths out there who are just users. We should have a much higher standard of coding. Closure is the right step in this direction, because I think functional programming is superior in getting code right and getting it useful code right to the users out there. But we need to think that way. That's the only way to think properly. Okay, so take that slide home too. Anybody want to take a picture real quick? All right. I love untyped programming. To this day, I almost never start in typed bracket. Even though it's 10 years old now, it's really mature, it's used by companies. Some companies apparently make a lot of money on it, but it's not my thing. And it probably isn't yours either. Part of it is I explore with code. You explore with code. Part of it is I know what I'm doing. I'm a macho man, or you're a macho woman, or whatever it is. We don't need that type stuff. Of course, it's in my head anyway. And then I catch myself, oh man, I should have written it down, And so I have this ongoing research program, and I pursued this research program for a long time. In essence, I've pursued this research program for 30 years. Okay? And now I'm in a position where I can actually execute. And when my share of the code base is relatively small. It's about 20,000, 25,000 lines of code. But it's at the very surface that middle school and high school students or freshmen see. So I have to be careful. When I open things now, I add types. And I'm incredibly careful in doing it right. Okay? It saves me time. My kids are old enough, they don't need me anymore. Vacation, I love my profession. Why should I take a vacation, But it really saves me time for doing more things. There's so many things on my plate still. I'm close to death, so, you never know what you get. But you also want to add value to your grandmother's life. And types help you there too. Okay? So don't dismiss them as, oh, I know they only catch typos. They catch typos in Java. But you're in Closure. You are thinking rich thoughts about types. You have a very refined way of thinking about things. You're composing these things. That's where it helps. Nobody else composes stuff. The only composition operator in Java is semicolon. Void composed with void. You have 2 voids now. Right? You are composing expressions. You're composing functions. You're composing functors. You will have them one day. Okay? And that composition works because you've picked your types right and you have them in your head. And sometimes you want to write them down because then you have them checked and they are true once and for all. Because you will get a sound type closure language too. It's a research program. we have built a hybrid language where you can play with this, and I encourage you to go out there and play with Racket and TypeRacket, just to get a sense of how it works. For example, how you compose many modules, and we blame exactly the place where it goes wrong. You will see as a developer, oh, I know how to fix that because it's at the boundary. This one is wrong. This one, you know exactly what's going on. Okay, so just play with it. So I'm not saying abandon closure, but Racket really is much cooler. Okay, with that said, thank you very much. It was great to talk to you. Questions? Do you have a book? No. You have one?
Oh, I have some.
Okay, good.
How do you think about the future of type closure and gradual typing? Do you think they'll ever achieve the same level of success as TypeRacket?
So I just had dinner with Ambrose in Europe, actually, last week, and because he came to give a talk, and he's slowly moving. He realizes what he did wrong. And he said to us, to Sam and somebody else and me, actually the inventor of RabbitMQ. So what he said was, I was a master's student. I literally copied Sam's work and didn't know what I was doing. And because I didn't know what I was doing, and this contract stuff was not in Closure, and I don't have proxy values in the JVM, I didn't know what to do. So I just abandoned it because I didn't think it was a big deal. And now, of course, now he completely understands. And he went to Indiana because he wants to work with Sam on this project. So he's clearly thinking, he has ideas on how to add the necessary mechanisms, these contract proxies. But I want to warn you, it's expensive. And we have to figure out how to make them cheap. So a parallel project that we're running in different places is a JIT compiler that is really aware, much more aware than we are now, of the proxies and can push through. So for example, we have reduced the overhead by factors already. So there is hope. I think very long term. I think about 20 years. That's long term. And I don't know, but you don't have that time. So don't wait for us. But pray for us that we succeed in our research program.
Can we skip the party so you can explain why something on there, type inference doesn't work?
So we have a first, a move to skip the party. Is there a second? Don't do that. I have to make up a talk. So maybe I come back one day. There's a bunch of things that are just obvious. I will tell you, I learned a lot, and I see a lot of repetition, and it's just wonderful. It would be much more wonderful if we had a much closer connection. So one of the things I've been talking about is that some of you should maybe get together and talk about putting closure where I put it in the early education, because algebra is the key element of education in school, and it has an incredible impact on the kids. With Closure and Racket and the teaching languages, as we call them, you can make huge progress in bringing across to kids who never understood math to say, like, this is cool stuff. We have hundreds and thousands of teachers that do that. Really works. Okay. So another thing I would like to encourage is that you just rewrite the books that I wrote. Hey, they're online, right? In Closure, you know. You should never have a junior developer stand up ever again and say, recursion was magic to me. Because it's your bread and butter. And these books do that. And Fibonacci or factorial are ruled out from those books. They don't teach factorial. They don't teach recursion. Recursion is when the structure of the code matches the structure of the type, even if the types are just in comments. So those are things that you can easily inherit from us. There's a lot of useful work that we need to integrate from you guys, from your world to ours. And I'm going to go home and get this going right now. Actually, I'm going to start a long email as I walk out before the party starts, right? So that's how I see things happening. I think Racket and Closure could really merge over time, merge in a conceptual sense, not in a concrete sense. And that would be wonderful to see.
So I guess I'll be the iconoclast here.
I am the iconoclast. It says on my webpage.
So types are really a way to narrow, the soundness is about narrowing down where the problem is.
Yes.
Couldn't you make the argument that having 100% branch and line coverage on tests, such
Great question. Right? Fantastic question. It turns out I was in business school when I came to this country and moved over to computer science because business school was so boring. Just don't say that anywhere. And the first thing I took was a class. There was 10 kids, 8 girls and 2 boys. It was wonderful. But it was about testing. Okay. Back then, computer science was a female-dominated undergraduate major, not a male one. What the first class was on testing. And it's a basic theorem. You cannot test all possible paths, period. That was the question. Can't we just test enough? And the answer is no. Types mean I prove for all. Your data set is infinite. Even your streams are infinite. And so like one little value in the infinite world is infinite, right? This is big infinite. It's infinite of infinite. Right? You can't test that. That's where types come in. They prove it once and for all. Okay. More questions? Back there.
What are your opinions of prismatic schema?
I couldn't quite hear the last part.
Prismatic schema?
Oh, you mean? No. I'm sorry. I'm not a closure man. I'm a racketeer. Oh, that's what contracts are. Okay. Sorry, I got it. I didn't hear the word, and it just clicked to me. In '98, I realized that I could get away with what's called contracts or assertions. That's what I thought. So, and I kind of knew I would need it eventually. So I built this contract library, of course, and I realized higher order values, like lazy streams, or first-class functions, or objects, they mess you up. They just mess you up. Because then when something bad happens, it's not even on the stack anymore. Okay. So that's why we spent 5 years exploring the proxy wrappers to get that right, both in theory and in practice. Okay. And then we realized, oh, programmers use them all the time. Cool. But you know what they use them for? They thought they were writing down types. But there aren't types. There are no types in 2 senses. Types are free. When they're checked, they have no runtime cost. And psst, they actually improve your runtime. I didn't want to talk about this, but types actually help. So when we run type bracket, fully typed converted code, it runs at 70% of the runtime. And we haven't even started yet on type optimizations. Okay, contracts are not free at all. Higher order contracts allocate, and as an old Lisp says, when you have performance problems, count all the conses and all the lambdas in your code, or funds, whatever you call them. Okay, because allocation is evil. So contracts in that world allocate is evil. They have a penetration cost, it's evil. We just don't know how to cope. So contracts are good for a little bit of checking and for expressing very complicated thoughts that we don't know how to write on in types. And I write those contracts a lot. Okay. But in this sense of replacing types, not at all. Next question.
What's the future of typing systems? How do you see it?
Oh.
Are we looking to build the whole software is fundamentally flawed.
Yes, I understand. If you promise not to tweet anything, I will tell you the truth. If there's anybody here who has a phone, then I will not say what I think. Okay, good. In that case, so where's academic research going? Where it's going is type systems that are far more powerful than anything you have seen here. We can write down far more interesting predictions now than you could in the past. As a result, you can use types, these kind of types, to prove the correctness of a C compiler. Has anybody here heard of CompCert? Okay. That's a project that came out of Xavier Leroy's research lab at INRIA in France. And they proved the first C compiler correct. Why? The French have had have a long history of putting code that is written in very high-level languages, very functional or time-oriented languages, into the Airbus. Okay, that's an airplane. It flies around like this, you know. So then they want to know whether that really works. So Cousteau the Cousteau family has verified, for example, that no floating point calculations on the Airbus can ever go wrong. They use a type-like system to analyze the bits into which they are compiled. So they cannot analyze the types at the source level because they don't know whether the compiler does the right thing. So they analyze the bit-level outcome of the compilation process. Obviously, what you want is you want a compiler for embedded systems that has 100% defined behavior, and that's what they did. So that type system can write down such tight thoughts about what a compiler does that you can eventually run this type-checking thingy. It's a very complicated type-checking thingy. And it says, this compiler is correct. And it will always do what I wrote down there on that page and nothing else. That's amazing. But here, I give you, so at the moment, DARPA is running a project where they're putting the same kind of things into drones and mine-clearing robots. Some of my academic colleagues do that, and they are able to do similar things. Okay. I give you a rough idea of what it means. When you write one line of code, you write 70 lines of types. Okay. Do you understand why I prefer to write untyped code? Okay, but don't tweet that. Any more questions? Now it's you who's standing between the party and us, right? Here.
Related to your last comment there was exactly what I was thinking when you were talking about making the type checkers stronger. Yeah. There is a really, I find, useful balance between being
yes.
explore and then have that.
Yes.
Is there work being done at that level as well?
That's me. I call myself a radical centrist in politics too. There are too few of us, right? And what I mean by that is you don't want to go to extremes. You don't want to be an ideologue that says untyped is the best thing ever, and you don't want to say writing 70 lines of code, 70 lines of types per line of code is heaven. It isn't, okay? For the ordinary programmer on the street, you want to find just the right balance. That's been my goal for my research career, and I was going to do that for the rest of my life.
Would you ever consider having an alternate standard library that's friendlier to types, or is that sort of off limits and you just want to meet the standard library where it's at?
So the question is, should we change the standard library to accommodate the type system? If you design a programming language from scratch and you're happy with 3 users, that's a great way to go. But I'm one of the things I do as an academic, I actually try to look into the real world and say, what are the problems that they're facing? They wrote an enormous amount of untyped code. Oh, easy. I'm just, like Bob, for example, I'm just going to tell them, throw your code away and rewrite in ML or Haskell. I'm sorry, it doesn't work that way. So changing the standard, so in my mind, there are 2 parts of the language that you don't change. Well, you change them, but you change them carefully and gradually and very slowly. And that's the core language and the standard library. Okay, you pull out the rug underneath from programmers because they're used to the names, to the behavior, to things. In Racket land, we go to extremes to remain backward compatible. And we sometimes preserve errors to be backwards compatible. It sounds odd, and when we do that, I always get into an argument with my colleagues, but they're right. Okay, more questions? Over there. Yes. So I gave up on inference actually around 95 by reading a very influential paper that never saw the day of light. Is there anybody here who remembers DEC-CIRC? Research lab in California? Okay. So the technical report, it's buried. So DEC was bought by, I think, Compaq, which you probably don't remember either. And then it was bought by HP, which you probably won't remember next year. Oh, I didn't say that. And so they had this incredibly famous research lab that has a humongous amount of great stuff. So Java was really inspired by Modular 3 from that lab. So the tech report called Typeful Programming by Luca Cardelli. And what he writes there is really, it's about types. What you want to do is you want to move into the IDE, the type inferencer. But if it fails, programmer just writes untypes. Okay. Here's another example that we want, and we have already built. We have a tool that tells you which contract boundary, which boundary between typed land and untyped land is the expensive one. So we can inject measurement probes and measure the cost of a feature. Right? Most profilers measure the cost of lines or maybe functions. We measure the cost of proxy values. Of course, there are lots of proxy values, and they will tell you that proxy value generated there consumes 80% of the time, and we find that. Here's another tool. So in addition to helping you infer the types that you have written down because you're dealing with a module, you might want to have help in constructing interfaces that are more suitable for the rest of the code. Or you can have a tool that takes a test suite and runs a test suite and suggests code to you. Some of you may know Diamond Ruby or DRuby. Comes out of Maryland. It's a very prototypish Ruby version, but they already can do that. So we're now trying to integrate this into our world. So we have a tool in the IDE that can help you make these types very quickly. So there's lots of room for building tools that help you with that task.
Have you done any work with Eiffel, the guy that made Eiffel and designed by contracts?
Yes. We wrote the paper that says Eiffel contracts are bad. So the question was, do I know Eiffel? Of course I know Eiffel. Eiffel is a language that originated contracts in OO land. And what they did there is it turns out they forgot about inheritance. I don't know how you can do that in an OO world, but they forgot about inheritance. And so contracts, at the time when I started exploring contracts for Racket, I actually started with Eiffel. And the first thing we did is we ran the program with a little class chain, and it ran to completion, 42. But we had actually baked in a bug and wanted to see how the contract system reports the bug. Like, that was odd, 42. So we wrote a paper on how Eiffel failed, Eiffel's source level contracts fail the intuition of the programmer. And they fixed some of that in the meantime, but it's still not right. So I give you room for one more question, and that's the thing what you get for it. Okay, there's one back there. You were first.
A future where you'll have virtual machine support for higher level types, or is that really unrealistic?
That's an amazingly cool question. Can a VM deal with types that are high level? And by high level, you can mean two things. One of them could be high level in the sense of, very nested type structure arrows. Another one could be these dependent types that I mentioned before. And yes, people will work on that. How far that goes, I don't know. But if you think about a dependent type, where you can say something about, here's a value coming in, and the result type is shaped by the runtime value. Right? A chip could exploit that and specialize the body for this range of values that we find good. And we already do that now by inferring at runtime what's still going on. But with dependent types, we can do it with upfront compilation already and don't have to wait for the warm-up to do that. So there's clearly opportunity for doing these things. There's opportunity for using contracts to push the contract assertions through a method or a function and improve that runtime cost, actually in the compiler as opposed to the VM. So there's lots of room for that performance improvement. I won't be able to do it all. If you want to be a PhD student, you just Google my first name, and it's on the first page. Send me an email.